Okay, so welcome to this new tutorial. Today we're talking about cache warp. Not really. We're talking about AMD-SEV. This particular attack, cache warp, does attack uh, this AMD-SEV. However, microcode's already been released, and it's not the first time SEV has been attacked. It certainly won't be the last time that it'll be attacked. So outside of the fancy domain name and the fancy logo, it's kind of whatever. We still think using AMD secure encrypted virtualization is a good idea if you're going to be anal about security, or you just want things very isolated. So today we're going to show you how to enable this for your Unikernels. Let's get into it. So we switch on over here to our shell here. We'll look at the config that we're going to use. You're going to need the latest nightly of ops and nanos for this, because this just made it in last week, depending on when you're viewing this video. But yeah, we take a look at our cloud config, bucket name. Obviously, we have that. Confidential VM is a Boolean. So this is not enabled by default for lots of different reasons. Yes, there is a performance hit that you're going to get. It's kind of negligible though. Some people have measured it up to 6%. I don't know. It's enough to where it's not on by default. The other reason that it's not on by default is that it's actually not available for every instance in every region. So in fact, I even specified my flavor as N2D standard 2, basically stating that, hey, I need this instance type. You can get the list of instances and flavors that Google will support just by going to their page. But in particular, yes, this means that we need an AMD processor, and further, it means we need either Rome or Milan as that flavor. So that's why the flavor's there. Then we got our image create, right? So here we ops image create. We're gonna pass it our program, pass it our config sub.json. Say we want on the Google provider. I'm giving it the project ID, the zone. This -n is for nightly, and then I'm just calling it, naming the image sev3 because I was playing around with it a few times. I'm on a Mac, so I'm doing --arch AMD64. So I've already compiled this for 64, even though this is ARM. And so that will create the image. Let's go ahead and spin one up if I have my command handy. So in this case, we're going to do ops instance create sub.json for 8080, basically normal stuff. So we do that. And it's spinning it up. You'll notice that I'm just using this image that I already created. All right, so it's spawn 995 is our new instance. Let's go in here and let's just let's pull this up. Okay, so we have it pulled up, and you can, looks normal, right? I'm gonna click on logging. And this is interesting because now we can kind of see that our attestation report is actually generated. So right here, you can see this second line. We click in it, and this little JSON stanza sev launch attestation report. Integrity evaluation passed true, which is a good thing. You can also look at sev policy. These are basically just bit flags that get set, telling you kind of like what is what. Basically, the background is that when the VM boots, an encryption key is made, and that's used during the lifetime of the instance. This is a key that Google themselves don't actually have access to. So, when I was talking about being paranoid and anal about security earlier, this is something that you might choose if that applies to you. And so yeah, this is a cool new feature. I would expect to see this sort of technology evolve and spread out through all the clouds and become kind of almost a standard in the coming years because it's just so important. You know, things like cache warp attacks aside. All right, so till next time, talk to you later.